And it's Clive Roxinger here. Now, the whole idea of AES, in contrast to regular electronics, is circuit design. What I'm trying to do is have full control over the design of circuits. Now, in this particular case, I've got a little diode set up here with 200 ohm connected to it. I'm going to turn the light off. Now, the motor's reading, what have we got there? I think we got it on lux. It's reading well, 33, 34, 33, 30, 33 lux, roughly. Now, what I've found is to turn this up. You can have a look at the ceiling. Turn that off. I'll connect up 100 ohm. And then again. And turn it on. And lux. Now we're reading 45 lux. From that it's a fair bit brighter. The whole idea of this is to be able to design circuits that do what I want them to do. You need power over the electronics. The thing about electronics books and courses is you have preset circuits with preset voltages and currents, and they give you the pictures and they tell you how to hook it all up, and you hook it up and say, oh look, I'm an electronics technician. But if you want to design the circuit to do exactly, now what I've done is I've increased the brightness of the LED because I wasn't happy with the output I was getting from 470 ohm. I dropped it right down to 100 ohm and I'm getting a little bit of a brighter light. The trick would be now to find out what the threshold of this is and how much brightness I can get out of it without burning it out, and push it to the limit and burn a few LEDs out and find out how much power I can run through them and how low I can drop that ohmage and what sort of wattages are in the circuit. The reason I'm doing this is because with this other circuit that I'm doing here, what I want to do, I had the, you've seen me high current breadboard. This is the thing here I want to connect this up with. And what this is it's a little voltage divider, and one of those is going to be a resistor. And the idea is I can calibrate the voltage because batteries lose power. So if I set a voltage divider up for 7.2 volt, I'll come back the next day and it'll drop down to 6.5 and it won't trigger the gate. So I need to have a higher input voltage which is coming through those other batteries which I showed you before, which is about 10 volt. And then I just calibrate it by adjusting the variable resistor to adjust the resistance, so I'm getting 7.2 volt output, and then that runs in parallel to the circuit, which means it should allow the current to flow, hopefully, in the circuit. And if I put the right resistance on well, I should be able to power the circuit to 7 volt and allow it to draw current. That's technically what I want to do, but I need to be able to calibrate it and set it to exactly the levels that I want. So it's exactly 7.2 volt, and then I turn the circuit on and it draws whatever current it needs. So I'm hoping that's how this works. So this is successful. So I've successfully changed the luminosity of the little LED. That's nice. That's a nice little bright light there now. I'm pretty happy with that. 100 ohm. And I'll now try and design this circuit with mathematics. This one here, which is what I designed it for, and one of those is going to be pulled out and it'll be a variable resistor, and it'll have to be fairly high wattage, and they're expensive too. I think I need about a 5k, and around about between a 5 and 10 watt. I think the highest I could get was a 5 watt. So I'll see how I go with that. Clive Roxinger signing off. Thank you for watching.